Hi there. Today in this video I'm just going to teach you something regarding Vernier scale. Most of the students find it really difficult to find out why Vernier scale is there. So actually Vernier scale is a really essential device that we have to use. The Vernier devices. Vernier devices are very different, and linear Vernier devices and circular Vernier devices. By the way, we need to just firstly learn to understand what is a Vernier scale. So in this video you will see these things: Vernier scale, the inversion, the mathematical stuff, and the standard Vernier scale, and how does it change in this one, and how does it shift when it's just going to shifting, so like this. And how does it exactly change with this type of very small variation. And very next up, kind of Vernier scale reading, pure Vernier scale readings, and how to obtain it. Okay, so go back to the first page. In this one I'm going to teach you regarding what is a Vernier scale. So actually French scientists who found this scale, because in a regular mid ruler, so it's going to be really tough to read this. If I just enlarge this one and show you, so when this, can we this just divide this into further 10 such divisions into one scale to make the least count very small, because we know the percentage error equation is going to be 1 is equals to least count over reading. The reading is going to be 10 centimeters for this one. So if you want to reduce the margin of 10 centimeter, we have to reduce the least count as well. But in a millimeter scale, in a meter ruler, it has a least count of millimeter, so we can't divide millimeter into furthermore. So if even though we can divide it, it's very difficult to measure, because see, because why? The reason is, the main reason for that is nothing other than our eye sensitivity, because the eye can only recognize somewhere like 100 micrometer means 100 micrometer means 0.1 millimeter. That's the exact margin if I divide 1 millimeter into 10 equal divisions, so it is not going to help. So they have to come up with certain new way. New method is nothing other than just finding it out with what respect to something called Vernier scale. In the Vernier scale, the principle is really simple. You have to select certain n number of a certain main scale. So in this case, if that is millimeters, so n number of millimeters. So in this one I have just taken like so 14 such stuff. So this is 14, the Vernier scale, and this one is the main scale. Vernier scale should be one more, that means it should be n, simple n plus 1, so I can easily mark it like capital N. So it is going to be 15 if only for this example only. So I can write this one like so, this way: n is equals to n plus 1, one of the mathematical assumption we can arrive. And again, the least count of the Vernier scale, because you took how many divisions, n divisions of the main scale, you divide it by n plus 1. So you can write it n plus 1. This is going to be the main scale reading. So in another way you can write it like n over capital N from this one. So this one is really essential as well, because your teacher might have only taught you this part. So sorry, this part. So this one is also really going to be essential to remember, because MCQs can come up with many ways. Okay, uh, let me just open up another page and show you some important calculations regarding that one. How? So technically I just obtained the least count of the Vernier scale. What is the least count? The least count is n over capital N. So how to find out the least count of the Vernier caliper? So what is the least count of the Vernier caliper? In a Vernier caliper, if that is marked by 1 millimeter scale, and this one is going to be something, so for standard one 0.9. In the same way, if this one is x, so this is the fraction of xy, x over n. This is the fraction because I just divided. So I have to show you something really important. So it's going to be 1 minus n over capital N. So this is the least count of the vernier caliper. Least count of the vernier caliper. But this one is only valid for what? Millimeter scale. If you have some other scale, so you have to come up with x. If the stuff is x, like so millimeter, something relevant to that, so you divided how n number of x's over capital N. So why did I multiply? Because the total length of the n particles. So because you took certain number of n, so the total length is n times x divided by n. This is the least count, and you are going to subtract, so you can just get the x out because it is the common factor. So it's going to be n minus n over capital N. This is one of the important equation that you have to obtain. So I told you something different. What for n you can obtain, apply this result. N is equals to n plus 1. So sometimes it may appear, so in MCQs most of the time it's going to be n over n plus 1. If you see this one, don't confuse, or some other way. So n, simple n equals n minus 1. So you may apply this into here as well and obtain this equation. So x times 1 minus n minus 1. So n minus 1 over n. So anything is possible. So it's all about the vernier scale. So let's go for standard vernier scale. So as I just mentioned earlier, so meter ruler is no longer going to help us. So we have to find out something different and new. That is nothing other than our vernier scale. How to use the vernier scale properly. So vernier scale is made out of 9 divisions of millimeter scale. 9 divisions of the millimeter scale. You just get this one, this is the n. N is equals to 9 here, and this is the going to be capital N. Capital N is equals to 10 because you always take what? N is going to be taken as n plus 1 always. So it is 1 plus 9, that is 10. You divide. So what is going to be the least count? LC of the vernier scale. So we know one thing, n over capital N. So what is n? 9 over 10. So the scale is millimeters. So the least count of the vernier scale is going to be 0.9 millimeters. It is really simple. See, you divided 9 divisions of main scale equivalents into 10 parts, into 10 divisions. So one, you may see there is a little bit difference between these two lines. So it's always there is a difference. So this is all about the main scale. So let me show you how does it happen. See, if I just get this one, see, so this is the main scale line, and see, vernier scale line is having a certain small difference. So the small difference can be represented here, very small yellow colored line, very small line, because it's that much of really small. So now let me just explain you this part. So now see, when I coincide this line with here, you may see it has some little more difference. So now I'm going to coincide this one. See, the difference is even bigger. Now it's going to be even bigger. See, now it's going to be even bigger, bigger, and bigger. There's a 0.9 difference here. So that is how it changes. So let me explain you something furthermore. So now you may see this one, really important to see. Why? I have marked this 1 millimeter into 10 equal divisions. If you slide slide this one, just passing exactly 1.1 millimeter line. 0.1 millimeter line. See which line has coincided now. Which green line has coincided? Only the first line. See, only the first line has coincided. No other line has coincided. See, the other one is having a difference, having a difference, having a difference, having a difference. So only the first line, because as long as you're sliding, there is a one difference for the first line. With the second line, you had a certain, when you move two um, fractions of 1 millimeter, because each of these lines are marked out with 0.1 millimeter. Why? Because this is a 1 millimeter. If I divide this into equally 10 parts, it is going to be 0.1 millimeter. Okay, now I've moved two lines. You may see this one, how long it has been moved, only coinciding with the second line here. No other line is coincided. Now let me just slide this furthermore, likes of the fifth one. Oh, no need to explain you all 10. Fifth line. Now see which line is coinciding exactly with this one. Okay, 1, 2, 3, 4. Oh, sorry. This one has a bit difference. 5. Like the same way, ninth one. Which line is coinciding now? If I just move to ninth line, see, only the ninth line is just going to coincide exactly. Like the same way, once I moved all 10, you may say just it comes to start halt like this. This is how you can demonstrate the motion. That means that when you move it furthermore, you can see, as I mentioned, so there is a difference, always there is a difference. See, small difference getting the bigger and bigger. Now let's take one small reading. See, now I will just move to one difference, so only always making contact with the coinciding with the first line. So the first line is coincided. So how to read it? So it's the first line. So least count is going to be measured in terms of this way: number of lines coincided multiplied by the least count of the Vernier scale. Sorry, reading. Vernier scale reading. VSR reading. What is the VSR reading? N times least count. What is the least count over here? It is 0.1 millimeter multiplied by what? Vernier scale has a 0.1 small least count of the Vernier division. So least count of the Vernier caliper. So multiply by number of divisions only 1. So it is like 0.1 millimeter in the Vernier scale reading. In the second one, see, now the second line has coincided. So it is like 0.1 multiplied by 2. It's like 0.2 millimeter for this one. This is for the first one. You might find something here. First line of the Vernier scale coincide with the first line of the main scale. Second line of the Vernier scale coincided with the second line of the main scale. It's going to be confusing. Don't worry, it is only for the first 0 to when you have a 0 line of the main scale coincide with the 0 line of the Vernier scale together, you have this combination. Now it is going to be really confusing if you just, or if I mention all represent to the 0 to 0. Now I'm going to show you something different. See, I started with the, actually not even with sixth one. Now it's 6.1, 6.2. Main scale reading is 6.2. Now I moved it to somewhere. See, first one, now There's a difference, difference. So only this one is exactly coincided. So what is the Vernier scale reading? Vernier scale reading is going to be 0.1 times, what is the line? 1 2 3. Always get the line of the Vernier scale. It's the third line, so number, that's third line, so 0.3 millimeter. Now I'm going to use this one, so it's the 2.1. I will tell you how to read the entire reading in the next video. I'm not going to extend this video too longer. So in this one, let's see which one has coincided here. It has just passed of the main scale. That's 2.1. Don't worry about that part, I'll teach you later, not in this video. Now the fourth line, it is the fourth. See, no other line has just coincided. This looks as if the coincided. Don't worry, so I'm just talking about this one. See, fourth line, so it's like what, 0.1 times 4 is like 0.4 millimeter of the Vernier scale reading. Now very next one. So which line it has just coincided now? Let me show you. First one no, second one no, third one no, fourth one no, fifth one yes. See, actually I'm just in the ascending, showing it in the ascending order: 1 2 3 4 5 6 8 9 10. But so have a good look at 7, and this line is what, 5, fifth one, and you may see 1 2 3 4 5, again 5 to 5. Remember that if you start with a baseline, main line, that means each whole number starting from your zero line just passed, if your zero line has just passed any main line, 1 2 3 4 100 or whatever, Vernier caliper is not that long. It's like if you are sliding between 1 to 2 to 3 to 4, any starting with the 0 just past the exactly a main line, so without any points, 7.1 7.2 like that, exactly starting with 7.0 2.0 or something like that, your reading is always going to be what, your reading is always coinciding the exact number of, if the fourth line coincided, also coincide with the fourth line of the main scale as well. That's only for exactly whole number. So you can again see in this one, now this is really challenging because number 5 is over here. Now you should know it is has just started with any decimal point of 4. What is the fourth one? So this is, if this is 1 4, so fifth, this is going to be 4.9, this is going to be what, 4.8. So it has just passed the 4.8 line. If you don't understand this quickly, because most, I have seen many students, they don't understand why, because we are counting back, counting forward is like 5.1 5.2 like that, no, so counting back is 5.9 4.9 4.8. It just zero line has just gone past the 4.8 line. So how to find out? So we don't want to worry about the main scale yet, because I'm not going to have any interest to teach you about main scale in this video. So in the Vernier scale stuff, so let's find how to drag this. I'm going to drag this line again. So I think it's better to draw another line rather than dragging it. Okay, let me drag. Still challenging. Okay, now it's actually sixth one I'm going to do, but I will going to show it. So now see which line, 6, no other line has just coincided. See, no other line, no other line, see, no other line, no other line, no other line. See, only the 6th line has just coincided with this one. So it is 6. So now see the main line, it is not the 6th line from here, but 1 2 3 4. So I told you, no, it started from some other way, not from any whole number of this one. This is a whole number, that's why you get the exactly same number from the main scale and the Vernier scale. For any other reading apart from any uh, base number, whole number, so you won't get it. So have a look at this is the sixth one. 6 times 0.1 is going to be 0.6 millimeter, right? So now you know what's the sequence. It's like the seventh line by 0.1 is 0.7. It's like eighth line by 0.1 it's going to be 0.8. So see, this is eighth line. This is the ninth line, so it is like 0.9 directly writing. So the 10th line, that means 0.10. No, it's like 1 millimeter. So that means you asked exactly on 0.1 line. That's what it say. Okay, so in the next video I'm going to teach you how to take readings. This video is all about how to take the least counts and how to take Vernier scale reading only. In the next video is going to be some real readings of Vernier scales. Okay,